Hello. Today right now I'm going to build this power supply. Now this power supply, it is built by a guy that's on YouTube, Spanish speaking guy, and these schematics here I have it from him. Uh, Now the way he did it, it was like the old way with like a pencil and a big sheet of paper. Now I find that way to be very time consuming, and I don't know, I'm just used to use like some kind of electronic design program. In my case it was easy EDA because I'm familiar with it. Now um, this power supply, the way he built it, he made it like on one board, and the board it was like this, I believe like this, 10 by 10 centimeters by 7 or something like that, or more, 15 by 7. It was a big chunk of PCB. Now I took these schematics and I put it like in easy EDA and made a PCB that I have it shipped to me, and they sent me this, which is way better than that and cheaper. It was like 5 of these were like €3, I think, 3 or 4 euros, less than €4. Now the thing that the way that I thought about this, it was that any component that can be removed of the board, I removed it. That means the diodes, the full bridge rectifier, the fuse, the switch, the small transformer, the 2 potentiometers which they're regulating the current, the voltage and the current, and I just removed that out of the board, and I try to put it like at the edge of the board so I can solder it better. I probably could do a better job in doing that, but hey, you will do this once, you will put it in an enclosure and it will stay there as long that it's going to function correctly. It doesn't really matter if you put it like, if you put a pad into a part or another part of a board. Now what I wanted to understand that the original board that this guy did, it was like 3 times, more than 3 times that I have here, because it's like bigger, it's like this and wider. So I don't really know how we did it, because on his Patreon he offered me the PCB for the power supply, but yeah, I find it way easier to design one. Now I'm going to solder this. I have here all the components, and the majority of them, they are what they need to be, except the capacitor, that this one here, it's at 25 volts, it should be at 50 volts, but I didn't find one in my junk boxes, and I kind of like get lazy and didn't ended up not going to buy one. Anyway, this power supply, I built it before, I have it here, and I'm gonna use it as a driver. Now because it's a linear power supply, I noticed something very, I don't know, I didn't expect it, let's say like that. I have this soldering iron, which it's nice, I like it. And this soldering iron needs a driver, a power supply that provides like power for the pen, for the solder. The thing is that I have a tip here that it's if you buy original tips, it's no problem. You can use the cable and this beefy adapter, wall adapter that they give you 65 watts, which is okay. It gives like 18 volts at 65 watts. With the original tips, that it's okay, it works phenomenally. But if I put in like these tips, these are, I believe they have like less resistance, and they are spiking like way more amps that that guy does, and just restarts. That doesn't work. So I have to put a current limit and just work work up the temperature up to the where I want to be, like 300-400 degree Celsius, and it will stabilize the current draw. It will stabilize like in 1 amp or less, depending what temperature I selected. Now when I use whatever current that I have on my power supply, it just burn out the USB-C connectors, because probably it went 6 amps, I don't know, and the pads inside this, they are not taking that. So I burn like 2 cables before I figure out I have to limit it like around 3 amps. I believe it's a safe 3.5 amps. It's like a safe environment. Anyway, I then went and buy this module, which is 5 amps. I just put it on 3 amps and 18 volts, so it will slowly go to 18 volts. But the problem is, this is a switch power supply, and I'm sure it's good for a lot of things, but it's not good for that one, because, well, that soldering iron, I think it uses like pulses that this power supply just is not I don't know, is not quick enough to compensate. So I only have it on the mounted, this I have it, but I had to put it like a 4700 microfarads capacitor at the exit, because some weird crap it happened. Like I have this voltmeter that you just put it here and it will work, and every time I plug the soldering iron, this voltmeter just went black, because something happened, and the voltages would happen there that this voltmeter will not measure anymore. It just went black. So I figured out I'm gonna put it on a linear power supply, which I have another one, and I put it on that linear power supply, and guess what? It hit it like faster at a constant current 3 amps, and this voltmeter didn't it worked perfectly. Now I'm gonna put this away. I already have built this power supply. I have it like here. Now this is the power supply already built. How you see, now I put like 2 diodes here and a 10 watts resistor. It's a shunt resistor, because this power supply, it should work like non-stop. So this will have like a different purpose, and this power supply goes like like here, and this is the voltmeter and ammeter. It works okay. And the other power supply that will go to the driver, that will go like as a driver, it will go in this plug, and this is here. It will tell me the voltage, and here it will tell me like the draw of current draw. Now this is not a voltmeter, it's something that I have from a musical amplifier or something like that, audio amplifier. So it will just tell me that current it's passing through there, at how much current. It's not scaled yet. It has some numbers there, but doesn't really, those numbers doesn't really say nothing. And it will go here, and it will stay like at 18 volts and 3 amps, 3.2, 3.5 amps. I'm not really decided that. I'll have to see that in the future. Now about the power supply, about the driver, that the first I kind of like probed it with this, so yeah, it worked, and after that I just ordered it from the internet. Now for the bridge rectifier, which is this here, I don't have it on the board. It will have to be somewhere outside it. I will use these Soviet diodes. I don't know from where I have it, but I have it from some time right now. And we am going with the transformer to this, and from this I'm going to the board. Now I don't have 2200 microfarads capacitor, so I'm gonna put one for 4700 micro capacitor, which, well, it should be okay, shouldn't be a problem with that. This will go the last one. Now I have the resistors here, which well, I took it out from this here because, well, normally I bought this from internet, a box like this, which was like, I believe at the time that I bought it, it was like 4 or 5 euros, something like that. And the transistors, the same, I buy from AliExpress, the same as the box with resistors. And all these are bought from AliExpress or at some point, or I don't know, this I don't know where it is from. I will use this as a shunt. Now because this driver, it will not always go at, it's not designed to go long periods of time at 3-4 amps, which normally this power supply is rated. It will go 3 amps for a few seconds. After that it will stay like 1 amp. So this resistor, it should be okay. I believe this is 0.22 ohms as the drawing says, but that is a catch. You have to calibrate it if you want to do it, because that is very much influenced by the others components that you will put it on the board. So yeah, you should calibrate that with more resistances or something, or in some way. Now before getting to the resistor, that mine on that power supply, it's 0.23 ohms. I had this one that it's 0.1 ohm. This will get to the power supply up to 6 amps, but I don't think the transistor will work that for a long period of time. It will just blow up eventually. So yeah, the power supply is designed up to 4 amps, so you should take it there. You can put it I mean, you can make it to be better, yes, but you will have to do something else on the board. I mean, put another transistor or something like that. I mean, this transistor uh, TUN 3055 or TIP 3055, it's rated for I think 60 watts, so you shouldn't pass that. Um, okay, so another thing that I did on this power supply, it was I changed these transistors here, BC167. It came with original designs. I didn't really realize at the time, so I designed these boards with BC167, but I believe it's the same, or if not better, putting 2N2222. This is a better transistor that it works. I find that it works better on this board than BC167. If you do that, if at some point you have to improvise it that well, you should. I took very seriously I took into consideration the legs of the transistor because they are different. So this transistor, it will not go like the draw on the board says. I'll have to like put it like bend the legs in such a way that the base will go or should hit where it has to go on the board, and the collector and emitter the same. Well, it just doesn't end. It doesn't go how it is on this board. I have another board, but I didn't order that because I already ordered this. Now the order, these capacitors, the same. AliExpress, €1, something, 1.5 euros. This diode, the same. Now this diode, they in the original plans indicates that this 1N5408, but I believe you can put like any kind of Shopee diode. I don't know what's the purpose of this diode. I believe it's you don't have some kind of reverse voltage that will screw up with the shunt, or I don't know. So you have to put it. It will have to take the 4 amps or the amperes that you want to put it. In my case, 3 amps. Now, with no further, I'm just going to start and solder it on. Now I'll start by measuring all these resistors, which each one has to go into his I believe this is 1K, so we'll go there. This is like 46 ohms. Okay, 47 ohms. Okay. Okay, this is a 10K. Now, one of the rules that says one soldering components is that you will start with the smallest one once and go up from there. Now this is a 470 ohms, which is this one. it should be mentioned that these components are like standards all, so you should have no problem in finding these to buy it like anywhere in the world. So what this was, 10K. So we have a 10K here. Okay, and I believe I only have 2 more. This is a 1K resistor, so go here. So I believe this one will be the 82 ohms one, which it is. I'm going to put these 2 capacitors because no, I'm not going to put that. Now, because these are already shorted legs, it's like a little different, like harder to solder on. I don't see them. Okay, so That concludes the resistors. Now I'm gonna put the diodes here, which is it's a Zener diode, 8.2 volts, and it goes, well, the way it's marked. The diodes I bought it from AliExpress too, so it were like 10 of these. They were 1.5 euros or something like that. So I'm gonna clip that now. And I have like a rectifier diode. What's this one? This one is 1N4007 and goes like with the line. This is nice. And this new new software that we kind of like manage to produce every time, every while. Like I remember now, I believe that this power supply I tried to build it with when I had like 17 years old, when I was like 17 years old, like 20 some years ago, and I didn't really manage because it was difficult to design. I didn't have the experience, so yeah, a lot of inconvenience, let's say. Now I'm going to put this capacitor, which is the wrong capacitor, but I believe it will work. I hope it will work. I want to do another. This is an MCMD capacitor, so it's surface mount. It shouldn't be here, but it's what I have. I mean, if it pops up, not that big of a deal. I'm just going to put another one. Yeah, I believe I screwed up here. Okay, so it's soldered. It's at 25 volts. My soldering iron operates at 18 volts, so it shouldn't go. It shouldn't have to go over that. If at some point it goes, well, this will blow up and that's it. I have to put. I have to go and buy one. Now, I'm going to put the 3K potentiometer, which I believe is this one. Yes. Now this potentiometer is for regulating the maximum voltage that the power supplies can provide. So okay, I'm going to put the transistors now because these transistors are not BC167, they are the 2N2022. The legs of these transistors, they are this thing, different, like this. So I have to change the base with the collector. The collector will go in the middle. So I'm just going to take a pair of tweezers and put this back, put this in front, and just make it in such a way that it will not touch each other. That will not be nice. Okay. Okay, the collector is in the middle and the base it's on the right. So let's try. Seems like okay, so I'll probably leave it like how it is. Now the transistor legs are very thin and very brittle, so I really don't enjoy doing this. So one of the problematic transistor is positioned. Now remember, this is a problem only because I have the wrong, not the wrong transistor, but the wrong board for the transistors. So that's why it's problematic. Now, what I didn't do is check for the transistor if it's okay. Now, that is a very important thing that you have to do. And it's a very simple way to do it. Now, with the base, which is this one, it should go both ways if you put it like positive, and with the negative it shouldn't. So this one it's okay. Now the BD, it's like the base shouldn't do nothing, and it should mark. This is okay, and the other. Now this is a very like rude way to look if it's something is wrong, but still you should do it. And I have to put the base collector in the middle, and the collector is out. Now I do the same, kind of like the same thing. Try to make it like not touch. Well, this looks like it's touching, so I have to. Okay, so it looks okay, it will stay like that. Okay, so I'm gonna mount these other things here and I'm gonna go back. Okay, so right now I kind of like mounted all the components. This capacitor, it's his turn right now. So now the resistor here, it should probably be, when I mounted the other ones, I noticed that if this gets hot, I will have in readings of a current, it will fluctuate a little. So you should have it this way of the board, as well as the diode, because it will get hot, and if they are passing that heat to the other components, well, the power supply won't work like okay. So yeah, now the beefy transistor, that is the final transistor, the amplifier, the power transistor, I already have it on the heatsink. Here is this transistor and goes to these wires, and the transformer is this one here, and I have to put it like 220 volts. Let's see how I can do that, and we should be good to go. Now I'm going to mount all of that. I'm going to mount all of that, and I want to mount this diode rectifier. This is minus and the other one is plus, and the alternative will go to the plates. So yeah, I'm gonna do that and be back. Okay, so I soldered all the components. This is the out, and this is in. It should be nice to have like two different colors, but I only have this wire, so it will have to do. The transistors, it's already on the heatsink, and the 9 volts alternative, it's here. I will have to connect it. So I'm just going to take the transformer and this goes this way. Okay. And this goes on the diode, and this let's see, to somehow okay. I should probably do this before. So this is the positive and negative. It will come like this, more or less. So this is the negative one. I'm just going to trim it. I mean, you can use a power supply, a switch power supply, and get rid of the bridge rectifier and the transformer, it will work very the same, I mean. But in my opinion, the transformer is like forever, so I'm trying to do that, to put the transformers in kind of like all my projects. And this is the positive one, which should go like down. Okay, so we are good. This is it, this is it, this is it. The transistor. Alright, so the power transistor that I'm going to use, it's this one here, and I have white for the base, green for the collector, and brown for the emitter. So I'm just going to quick trim it here. Base goes into the middle. This will probably stay like this, so I mean, my intention is to stay like this. I'm gonna make it right now, and the wires should remain like at this length. Okay. Okay. So have this one, have the base. So I have the base, and the green one I said is the collector. So now okay, the collector is done. I'm doing this like I'm sure it will work, so If it's not working, well, this is a loss of time. I mean, it should work. The other one it works, so yeah, shouldn't be a problem for this one. Okay, so this is the emitter. And it's done. Okay, how it is right now, it should work and it should respond when I move the potentiometers. So the potentiometers right now are in the middle. And I'm just going to measure the voltage, and this video is very long, so I'm going, if it all works, I'm just going to leave the testing kind of thing in another video. So it should work. Let's see. Oh, it's not. Okay, I have to plug it in. Now, yeah, I have like 7 volts. So let's see if I can trim that with a screwdriver. Okay, so it goes up to, so I need to be like 18 volts. Okay, now let's see what I did first. I just realized I didn't have it on camera. Now this is voltage and this is current. The current right now, I don't have an ammeter in series, so I'm gonna just pass it. This is voltage, this is amperage, and this is maximum voltage that I can like the superior limit of the power supply. Right now I have it in like 19 volts, 18, and let's put it in 18 volts. Okay, let's see what this does, if it does something. Yeah, it does something. This is the superior limit of the I'm just going to leave it in the middle. Going to put this in. Yeah, probably this spot is not like the best. Okay, right now what I'm gonna do, I'm just going to put like a bulb. I had it around here somewhere. Just going to put this. I don't know how many amps this will draw, but it will give me like a perspective of if it works or not, the current limit. This is, I don't know, it's 70 watts, 50 watts, 40 watts, 55 watts I think it is. $55 watts. At 12 volts, like 5 amps, it's overkill. Okay, I didn't. Okay, the transistor is back there, so this is the bulb. Okay, positive and obviously it goes right down. I don't know how many amps, but if I put it like this, it should go up. Okay, so it has like so it does. Now this transistor normally it needs to has like a heatsink, so it doesn't have this transistor here. I didn't put in one right now. I'm going to put one but it works, so it goes back. So the current limit, it works. This would be like 4 amps or 3 amps, 4 amps, around there. So yeah, it works. The diodes, they are getting warm, but and this transistor here, well, doesn't really means, doesn't seem that it has a problem. Let's see. I mean, yeah, this heatsink is not like the best for this transistor. But it will work. So yeah, it works. I'm gonna leave it like that. Thank you for watching. Bye.